So what is absolute value? What's it look like? How you know you're looking at an absolute value group? It has, those straight vertical bars. Those vertical bars. Could be a number inside. Could be a variable or an expression. Okay, so we have to be able to identify if it's an absolute value quantity or group. Our solving changes slightly. Before we do that though, let's understand what absolute value is first. So remember the definition of absolute value is asking you how far is that thing inside from 0. So here's two answers. They're going to be exactly the same because it's talking about a distance from 0. 3 on the number line is 3 away from 0. This is why it's equal to 3. And this is why this is also equal to 3. Negative 3 on the number line is also 3 away. These are both 3 units away from 0. So what does that have to do with solving? Well, it's telling us that we are going to have two different answers. So if we're looking at the absolute value of something, it could be a variable in there. Let's say it's a variable. And it's equal to a number here, like a positive 3. That means there's two possibilities that could be inside here to make this true. This quantity could equal a total of 3 or negative 3. It's still going to be 3. That's going to create two solutions most of the time when we solve. Alright, so we are solving these problems to see if we have those solutions, whether it's two solutions, one solution, or no solutions. We are going to always make sure to get the absolute value by itself first. So if there's things on the outside of the absolute value that are multiplying to the absolute value, or adding, subtracting, or dividing, you need to move them to the other side. Okay, do not touch the inside of the absolute value. So you have to undo, remember your undo operations to move things away from the absolute value group. Once you have it by itself, you're going to make two equations. Make two equations using the inside expression. The inside expression is the thing that's inside, captured by the absolute value symbols. Okay, and don't change it. Keep it exactly the same. What we're going to change is what they're going to equal. What they're going to equal. So we take that inside part, the absolute value of the expression, and make it equal a positive number. And then also make it equal the negative possibility. And then we're going to solve these two different equations. And we'll see that in our examples. Let's start with the easy one, where we're just looking at the absolute value of x. And they're telling us it's equal to 4. So we're looking for possible values of x to make that true. Possible values of x to make this true. A lot of us right now in our head are going, oh, I know the answer. What is it? 4 or negative 4. 4 or negative 4. So because there's two of these, I like to break these walls down and make two equations. So the inside expression is x. I'm going to use it twice. X. But one of them is going to equal a positive possibility here inside. This could equal 4 to equal 4 out here. Or this inside part could equal negative 4. And this is where our other equation comes from. the evil twin equation. All right, so typically we'll have more things to do, but hey, our x is already by itself and it's showing us our two different answers. And we thought that too. We knew that these two values were both 4 units away from 0. 4 units away from 0 on the number line. All right, here's another equation where everything's already inside for us. And what this is actually showing us is not the distance from 0. It's actually the distance from 2. You find distance between two things by subtracting. So this is actually showing us, hey, what numbers are 7 units away from positive 2 on the number line? If you have a number line, go ahead and look at it. All right, so in this problem, you don't have to understand, like I said earlier, this is a distance from 2, but I want to show you this conceptually. Let's go to number 2 over here on this wooden number line here. So here is 2. So we're looking at a distance of 7 in each direction. If you go 7 to the left, you go 1, 2, 3, 4, 5, 6, 7, you land on -5. -5 could be an answer. That's 7 away from 2. The other direction, if you go the other direction, 7 away, you end up on 9. All right, so that's the conceptual answer here, -5 or 9, based on this idea of distance from a target number that's not 0. But now let's solve this and back it up with some algebra. Break down the walls by making 2 equations. Never change the inside. So it's going to stay as x minus 2. That's a big common mistake people will make. It's 2 equations that use x minus 2. But one of them will equal positive 7 and the other one will equal -7. This is showing us our movement to the left 7 to the right 7. And if we solve these equations, we end up with our final answers that are going to match over here. Add 2 to both sides, you get x equals 9. X equals 9. Over here on this one, add 2 to both sides, and you get not 9, not -9, -5. So it's not always going to be the same numbers, just opposites. You actually have to do some algebra to figure it out. And there's that -5 that matches the other answer that we got on our number line. All right, here's our next example. And it looks a lot like the last one, except for what? So small difference here is our -2 is no longer inside like the last example. It's now on the outside. So we have to move it before we start breaking down the walls. Okay, so move that -2 over by doing the opposite. I want to add 2 to both sides to move it. I'm going to add 2. That leaves me with the absolute value of x by itself equals 9. Now the group is by itself. Separate and solve. But we separate this one, it's already done because x is already by itself. Well, one answer will be positive 9 and one answer will be -9. All right, so some more examples where things on the outside that we have to take care of before we separate and solve. So in this one, we're going to have a couple things to take care of on the outside here. Got 2 times the quantity of the absolute value quantity. We have -6 minus x, and then -6. This will all equal 4. All equal 4. All right, so we're looking at getting rid of things that are not inside. Things that are not inside are the 2 and the -6. We're going to undo that stuff. We could also imagine that there's just a box around this. Let me make a different color box, doesn't go away. We can imagine there's a box here, and we're just going to undo things around that box. So we're going to add 6. What's the operation with this 2? It's multiplications. How are we going to undo this 2 then? We're going to divide. That's right, we're going to divide. All right, let me get rid of this box though. Boop. All right, first thing though, we're going to add 6 over both sides. So now we'll have 2 times our negative 6 minus x equals 10. Now this is where you could easily make a mistake. A lot of you want to distribute, huh? But remember the rule, don't change the inside. If you go distribute, you start changing the inside, and that's against our solving rules with absolute value. This has to stay the same. So instead of distributing, get rid of the 2 by dividing both sides by 2. We're undoing that stuff away from the group. So now the absolute value is by itself equals 5. This is now where you separate and solve. Now you have 2 possibilities in here. This could end up equaling negative 5, or all of it could add up to equal positive 5. And that's why we make 2 equations to find those answers. Break down the walls, using the inside does not change. The inside does not change. Negatives stay negative in there. Don't mess with them. What we mess with is the result here. It could equal positive 5, or it could equal negative 5. Let me get my right color here. Or it could equal negative 5. And now solve those 2-step equations. And once you do it once, you've actually done it twice because you're doing the same 2 steps, right? You add 6. And then divide by that number next to x. Same thing over here. Add 6, divide by negative 1. But wait, we got 2 answers that are negative. Is that possible? Yes, it is possible. It is possible. You don't always have to get one answer being positive, one answer being negative. If you were to plug these values in, they would satisfy the original equation way up here. It would satisfy the equation. So go ahead and do it. Negative 11 right there. Negative 6 minus negative 11. What does that become?
Negative 5. And then 5.
Negative 6 minus negative 11 becomes positive 5. And then the absolute value of 5 is still 5. 5 times 2? 10. 10 minus 6? 4. That verified negative 11. Let's do the same thing with negative 1. Negative 6 minus negative 1 is negative 5. The absolute value of negative 5 is 5. 5 times 2? 10. 10 minus 6? 4. See, it's okay to have 2 answers that are negative. It doesn't matter about the value of your answers. It matters that you separate and found that there's 2 possibilities here. Here's another example with stuff on the outside that we have to take care of first. And that thing on the outside is negative 4. And remember, you're always looking to undo the operation. If there's no operation between here, it's telling you it's multiplication. We're going to undo it with our division. So divide both sides by negative 4 to get that absolute value by itself. So now we have x plus 7 in absolute value, absolutely by itself, but what does it equal? Negative 3. And that's a problem, because now we're looking at a negative distance. We cannot have this in our answer. It looked good up here, equal to a positive number, but we couldn't make this decision until we get the absolute value by itself, then look over on the other side. If it's negative, like if this one is, no solution. There's no negative distance. Okay? So sometimes when you move things over, the sign might change. Imagine if I had negative 12 though right here. Now we can solve it because this turns into a positive 3, and now you make your two equations. Okay? But that's what it wasn't. It wasn't negative. Let me erase that little thing up there. Where's my eraser? There it is. Again, so no solution. You can't have the absolute value equal a negative. Okay, you can have negative solutions, but you can't have the absolute value equal a negative. All right, time for some pattern practice. All right, so we start the problem by getting things away from our absolute value box or group there. If it helps you, cover it up. That way you know not to touch it. Don't do anything to it. Get things away from it instead. So I start with this one always start with the adding, subtracting first. We're doing the opposite to move it over. And what happens is not only goes to 0 on the left-hand side, but also on the right-hand side. So negative 3 is still there. 2x minus 1 equals now 0. We're not by itself yet. So we're not completely by itself yet. We have to still divide by negative 3, and that's not going to change anything because 0 divided by anything is still 0. But we do have the absolute value by itself. 2x minus 1 by itself equals 0. And this is where we saw earlier in the notes that if we have an absolute value equal to 0, we're going to get one solution. Because if you go to make these equations, breaking down the walls here, we make two equations with the 2x minus 1. But we go to make a positive 0 and a negative 0. It's the same thing. There's no such thing. 0 is just 0. So we solve this, and we get the same answer for both equations. So you really only have to solve one of them. Add 1, divide by 2, and your answer, your only solution, one solution here is x is 1/2, or 0.5, or 0.5. All right, may the math be with you.